Hello everyone and welcome to the channel. It's always a blessing if we can just listen to someone who can help us run through the concepts and allow us the space to learn from anywhere, isn't it? And if you are someone who believes in listening, this podcast is for you. In this series, we will go over the AWS services on our new podcast episodes where we will go through the AWS documentation and grep the essential pointers which we can listen in our free time. So I hope you like it, and if you're new to the channel, then please do help the channel by subscribing to it and sharing it with your friends if you like the content. And if you're ready, let's begin with our first episode, AWS Elastic Compute. So what is Amazon EC2? Amazon Elastic Compute Cloud, or what we also call as Amazon EC2, provides scalable computing capacity in the Amazon Web Services cloud. Using Amazon EC2 eliminates your need to invest in hardware upfront, so you can develop and deploy applications faster. You can use Amazon EC2 to launch as many or as few virtual servers as you need. You can also configure security and networking and manage the storage as well. Amazon EC2 enables you to scale up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. That's a very good thing. So what are the features of Amazon EC2? Amazon EC2 provides a whole lot of features. The first thing being it provides us with a virtual computing environment, which is known as the instance. It also provides a pre-configured template for our instances known as Amazon Machine Images or AMIs that package the bits you need for your servers, which include the operating system and the additional software. It also provides various configurations of CPU, memory, storage, and network capacity or networking capacity for your instances, which is known as the instance types. The very best feature that I feel is you can have a secure login information for your instances using your key pairs. So AWS stores the public key and you store the private key in a secure place. It also provides storage volumes for temporary data that's deleted when you stop, hibernate, or terminate your instances, which are also known as instance store volumes. On the other hand, it also provides persistent storage volumes for your data using Amazon Elastic Block Storage, or what we also know it as Amazon EBS, or what we also call as Amazon EBS volumes. It provides us multiple physical locations for our resources such as instances and Amazon EBS volumes, which are one of the most important aspects, which are known as regions and availability zones. It provides us with a firewall that enables us to specify the protocol, ports, and source IP ranges that can reach your instances using security groups. It also provides static IPv4 addresses for dynamic cloud computing, known as elastic IP addresses, which are basically static. So it does not change upon restart. It also has a provision to provide us the details about the metadata, which are also known as tags, that we can create and assign to our Amazon EC2 resources. And the major part that we have is it can also provide us with the virtual networks, which we can create that are logically isolated from the rest of the AWS cloud, and that we can optionally connect to our own network known as virtual private clouds. So how do we make use of Amazon EC2? So there are three basic steps I would say. So first, you need to sign up for AWS. Second, you need to create a key pair. And the third one is basically to create a security group. So how do we sign up to AWS? So when you sign up to Amazon Web Services, your AWS account is automatically signed for all the services in AWS, including Amazon EC2. And the most important part that you have to remember is you are charged only for the services that you use. With Amazon EC2 as well, you pay only for what you use. If you are a new AWS customer, you can get started with Amazon EC2 for free. And how we can do that? Yes, by using the AWS free tier accounts. The next part that I said is create a key pair. So AWS uses a public key cryptography to secure the login information for our instances. A Linux instance has no password, so you use a key pair to log in to your instance securely. So you specify the name of the key pair when you launch your instance, then provide the private key when you log in using SSH. And if you haven't created a key pair already, you can create one by using the Amazon EC2 console while launching the instance itself. And the one thing that you have to note here is if you plan to launch instances in multiple regions, you'll need to create a key pair in each region. Yes. So if you're planning to launch instances in multiple regions, you need to create a key pair in each region. So it is very simple to create a key pair as well. So you just have to go to the Amazon EC2 console. You can go to the key pairs, choose create key pair, and you can provide a name. And optionally, you can provide a descriptive name for the key pair. And Amazon EC2 associates the public key with the name that you specify as the key name. A key name can include up to 255 ASCII characters, and it cannot include leading or trailing spaces. Important point. For the key type or the key pair type, you can either choose RSA or ED25519. And you have to remember that ED25519 keys are not supported for Windows instances. For private key file format, choose the format in which you want to save the private key. To save the private key in a format that can be used with OpenSSH, we can choose PEM. And to save the private key in a format that can be used by PuTTY, you can choose PPK. So there are two formats, basically like PEM and PPK. So mostly what happens is we choose PEM when we work on Linux instances, so that it's very easy for us to use it with OpenSSH. And when we're working on Windows machines to connect to any of the SSH, if we want to connect to the instances using SSH using PuTTY, then we choose PPK. So for Linux, it is PEM, and for Windows, obviously it will be PPK. Then you just need to choose create key pair and it will generate the key pair for you. And you have to remember that the private key file is automatically downloaded by your browser. The base file name is the name you specified as the name of your key pair, and the file extension is determined by the file format you choose. So if it is PEM, then it will be .pem, and if it was PPK that you chose, it will be .ppk. And you have to save the private key file in a safe place. And if you delete that or if you lose it, then you have to generate a new one. And one more thing that you have to understand is if you're using a Mac or a Linux computer to connect to your Linux instances, you have to change the permissions of your PEM file. So it will be chmod 400 so that you can only read it. So you have to just provide the command chmod space 400, that is 400, space keypair name .pem. And if you do not set these permissions, then you cannot connect to your instances using this key pair. So it's an important thing that you have to remember. The next thing is to create a security group. So security groups acts as a firewall for the associated instances, controlling both inbound and outbound traffic at the instance level. So remember that it is a controlling factor at the instance level, not the subnet level. It is for the instance level. So you must add rules to a security group that enables you to connect to your instances from your IP addresses using SSH. And you can also add rules that allow inbound or outbound, or it can be like you can allow inbound and outbound HTTP and HTTPS access from anywhere. And here as well, you have to remember that if you plan to launch instances in multiple regions, you will need to create a security group in each region. So if you create a security group in US West 2 and you have another region like AP Southeast 1, then you have to create a security group there as well. And here also you can just create the security groups using the Amazon EC2 console by going to security groups and then create security groups, and you can provide the inbound rules and the outbound rules that you want. And on this channel we already have a video which tells you how you can create the security groups, so you can watch that later on after listening to this podcast. So what are the best practices for Amazon EC2? Whenever we are learning something, it's always advisable for us to learn the best practices as well, which are provided by AWS themselves. So you know what is the best way to approach when you're using a service. To ensure the maximum benefit from AWS or Amazon EC2, AWS provides a set of best practices that we can choose from or we can read from. The first one is security. So here we can manage access to AWS resources and APIs, and we can do that by using identity federation, IAM users, and IAM roles. We can establish credential management policies and procedures for creating, distributing, rotating, and revoking AWS access credentials. And all these can be found in the IAM best practices as well. Our major impact would be how we are controlling the access. So it will be about implementing the least permissive rules for the security group. Only provide the rules that you need for your instances. And for security, the next biggest factor would be to regularly patch, update, and secure the operating system and applications on your instance. And if you want to find more information about how we can do that, you can read more on the documentation as well. Other than that, you can also make use of Amazon Inspector to automatically discover and scan Amazon EC2 instances for software vulnerabilities and unintended network exposures. That's also a very good service, so you can make use of that as well. The next best practice is from storage. So we need to understand the implications of the root device type for data persistence, backup, and recovery. It's always better to use a separate Amazon EBS volume for the operating system versus your data. And we need to ensure that the volume with the data that you have persists after instance termination. So that is why it is a very good thing to use the Amazon EBS volumes. And we can also make use of the instance store available for the instance that you have to store the data temporarily. But we need to remember that the data stored in instance store is deleted when you stop, hibernate, or terminate your instance. If you use instance store for database storage, ensure that you have a cluster with a replication factor that ensures fault tolerance. And it is always advisable to encrypt EBS volumes and snapshots. The next thing is resource management. So we can use instance metadata and custom resource tags to track and identify our AWS resources. And with our current limits for Amazon EC2, we can plan to request any limit increases in advance of the time that you will need them. We also have a service here as well, which can provide us with the information that we want, and that is AWS Trusted Advisor. So we can use AWS Trusted Advisor to inspect our AWS environment and then make recommendations when opportunities exist to save money, improve system availability and performance, and also help close the security gaps that we have. So AWS Trusted Advisor is a very important service, and it can help us in this for the resource management. The next one is backup and recovery. So if you have data, backup and recovery is very important. So it is always advisable to regularly backup the EBS volumes using Amazon EBS snapshots. and create an Amazon machine AMI from the instances that we have to save the configuration as a template for launching future instances. So if you have a set of operations that you want to perform within that AMI before it actually launches or on launch, then you can create AMIs from that so that whenever you want the same configuration, you can just create or launch more instances using that same AMI. And for backup and recovery, it is always essential if you can deploy critical components of your application across multiple availability zones and even replicate your data appropriately. It is always advisable to design the applications that we have to handle dynamic IP addressing when the instance restarts. Because if you know that if you terminate or restart the instance, if it does not have elastic IP, then as the IP addresses are dynamic, it will change. And the next thing that is very important as well is to ensure that you are prepared to handle failovers. For a basic solution, you can manually attach a network interface or elastic IP address to a replacement instance. So that's a very good thing. And for an automated solution, you can use Amazon EC2 auto scaling so that you have a failover mechanism. So even though one of the instances fails, if you have an automated solution in place, you can launch a instance automatically using the Amazon EC2 auto scaling. Testing is also very important, so regularly test the processes of recovering your instance and EBS volumes to ensure data and services are restored successfully. And when it comes to networking, the best practice is to set a time to live value for your application to 255 for IPv4 and IPv6. And here, if you use a smaller value, there is a risk that the TTL will expire while application traffic is in transit, causing reachability issues for your instances. Now that we discussed about Amazon EC2, the most important part for EC2 instance would be its AMI. So what is an Amazon Machine Image or AMI? So I hope you got the point. Amazon Machine Image is AMI. So an Amazon Machine Image or AMI is a supported and maintained image provided by AWS that provides the information required to launch an instance. Here, you must specify an AMI when you launch an instance. You can launch multiple instances from a single AMI when you require multiple instances with the same configuration. And you can use different AMIs to launch instances when you require instances with different configurations. So what does an AMI include? So it will include one or more Amazon Elastic Block Stores, EBS snapshots, or for instance store backed AMIs, a template for the root volume of the instance. For example, an operating system, an application server, and applications. It also includes launch permissions that control which AWS accounts can use the AMI to launch the instances. And it also has a block device mapping that specifies the volumes to attach to the instance when it is launched. So these 3 points are very important. So try to remember them. So how we can use the AMI? So obviously you have to create an AMI. And after you create and register an AMI, you can use it to launch the instances. And you can also launch instances from an AMI if the AMI owner grants you launch permissions. So if it is not yours, and if the AMI owner grants you the launch permissions, you can use that as well. You can as well copy an AMI within the same region or to different AWS regions. And when you no longer require an AMI, you can just deregister it. Or the other form of it, if you want to talk about it in simple terms, you can just delete it. You can just call it as deregister when it comes to AMIs. Here you can actually search for an AMI that meets the criteria for your instance. If you don't have one, You can search for AMIs provided by AWS or AMIs provided by the community. There is a vast array of AMIs that are available, and they are provided by the AWS community sites as well, or the community providers as well. So you can make use of them. And there are AWS provided AMIs as well, so you can make use of them as well. And make sure that you use AMIs from the trusted source only. And after you launch an instance from an AMI, you can connect to it using SSH that we already discussed. And when you are connecting to the instance, you can use it just like you use any other server. So how we can create our own AMIs? So you can launch an instance from an existing AMI, customize the instance. So like installing the softwares that you want on the instance, and then save this updated configuration as a custom AMI. So you can create AMIs from an existing instance as well. And then once you have this customized AMI available to you, instances launched from this new custom AMI will include the customizations that you made when you created the AMI. Let's suppose you have an instance and you have installed Nginx, Redis, or whatever softwares that you want, and you have created an AMI. The next time you launch the AMI or launch the instance using the same AMI that you created just now, you will have all these configurations saved along with the new instance that you have. So you will get the same customizations that you had in the previous instance that you launched previously with the customized AMI. And here the root storage device of the instance determines the process you will follow to create an AMI. So the root volume of an instance is either an Elastic Block Store or Amazon EBS volume or an instance store volume. And there are two different ways to create these AMIs. So there is a procedure to create a Amazon EBS backed AMI, and there is another process to actually create an instance store backed AMI as well. And to help categorize and manage your AMIs, you can assign custom tags to them so that you can identify them and make use of them later on. And one more interesting part when it comes to AMIs is that you can buy, share, and sell AMIs as well. So you can buy, share, and sell AMIs as well. So after you create an AMI, you can keep it private so that only you can use it, or you can share it with a specified list of AWS accounts. And you can also make your custom AMIs public to that of the community that we already discussed, so that the community can use it. And the most important part for us is building a safe, secure, usable AMI for public consumption. It is fairly straightforward process if you follow simple guidelines. And you can purchase AMI from a third party, including AMIs that come with service contracts from organizations such as Red Hat. And you can also create an AMI and sell it to other Amazon EC2 users. So we have shared AMIs that we create and share, and we also have paid AMIs. So what we do when we are done using the AMI, so as I already mentioned, we can also deregister the AMI. So we can deregister an AMI when we are finished working with it. And after you deregister an AMI, it can't be used to launch new instances. So remember that before deleting anything. And existing launched instances, or the existing instances that we have, is because you might have a doubt that what happens to the existing instances that have been created using that particular AMI. So what if we deregister an AMI and there are instances already launched with that particular AMI? So existing instances launched from the AMI are not affected. So don't worry about that. And when it comes to Amazon Linux AMIs, there are two variants of Linux AMIs that are supported. So one is Amazon Linux 2 and Amazon Linux AMIs. So Amazon Linux 2 and the Amazon Linux AMI are supported and maintained Linux images provided by AWS. And there are a few feature sets that are available to these AMIs. So they provide a stable, secure, and high performance execution environment for the applications running on Amazon EC2. They are provided at no additional charge to Amazon EC2 users. So they are free to use. Repository access to multiple versions of MySQL, PostgreSQL, Python, Ruby, Tomcat, and so many other common packages. The best part about them is they are regularly updated, or they are updated on regular basis to include the latest components, and these updates are also made available in Yum repositories for installation on running instances. It also includes packages that enable easy integration with AWS services such as the AWS CLI, Amazon EC2 API, and AMI tools, and also the Boto library for Python and the Elastic load balancing tools. So AWS provides a whole set of feature sets when it comes to using Amazon Linux 2 and Amazon Linux AMIs. And when it comes to choosing or selecting an AMI, we can do that based on the following characteristics. So the first one is region, second one is operating system, third one is the architecture itself, whether it could be 32-bit or 64-bit, and it could be the launch permissions, and the last one is storage for the root device. The first one that we wanted to discuss was launch permissions, because we already know the region, because if you have a AMI in one particular region, you have to copy it to the other region to make use of it. And it could be based on the operating system, because there are a lot of operating systems that we want to use. It could be Windows, it could be Linux, it could be open source, it could be Red Hat. So based on that you can use, and based on your requirement for the architecture, it could be 32-bit or 64-bit. So the next part that we wanted to discuss was launch permissions. So the owner of an AMI determines its availability by specifying launch permissions. And launch permissions fall into the following categories. So it could be public, where the owner itself grants launch permissions to all AWS accounts. So it is public. The next one is explicit. The owner grants permission or launch permissions to specific AWS accounts, organizations, or OUs, which are organizational units. That is explicit. So it explicitly defines who can make use of it. So here the owner actually has implicit launch permissions for an AMI. And I had already told you, based on storage as well, we have the categorization of AMIs. So storage for the root device. So all AMIs are categorized as either backed by Amazon EBS or backed by instance stores. When it comes to Amazon EBS backed AMIs, the root device that you have for an instance launched from the AMI is an EBS volume created from an EBS snapshot. Okay, so the root device for an instance launched from the AMI is an EBS volume created from the EBS snapshot itself. And when it comes to Amazon instance store backed AMIs, so the root device for an instance launched from the AMI is an instance store volume created from a template stored in Amazon S3. So this is the major difference. So one, which is EBS backed AMI, is created by EBS snapshot, and the other one, that is the instance store backed AMI, is basically created from a template stored in Amazon S3. And you might ask, what is the difference actually between them? So what could be the important differences between two types of AMIs? So the boot time for the instance is usually less than 1 minute in Amazon EBS backed AMIs. And when it comes to instance store backed AMIs, it is usually less than 5 minutes. So boot time for an instance is less than 1 minute for EBS backed, and less than 5 minutes when it comes to instance store backed AMIs. When it comes to size limit for the root device, for EBS backed AMIs, it is 64 terabytes, and for instance store backed AMIs, it is 10 GB. So the data persistence, as we already know, by default, the root volume is deleted when the instance terminates. Data on any EBS volume persists after instance termination by default. So when it comes to EBS backed AMIs, you are sure that the data that you have will be persisted even though the instance is terminated. And when it comes to instance store backed AMIs, data on any instance store volumes persist only during the life of the instance. So if you terminate it, then your data is lost. But the important part that you would want to know is the charges, how it is being priced. When it comes to EBS backed AMIs, you are charged for instance usage, EBS volume usage, and storing your AMI as an EBS snapshot. So that's a good thing because you are making use of the volume because you want to store them and make your data persistent. So you need to pay for that. And when it comes to instance store backed AMI, you are charged for instance usage, that is basically your EC2 instance usage, and storing your AMI in Amazon S3. And what happens to the instances when it is stopped? So when it comes to EBS backed AMIs, it can be stopped or it can be in a stopped state. Even when the instance is stopped and not running, the root volume is persisted in Amazon EBS. But unfortunately, in instance store backed AMIs, it cannot be in a stopped state at any given point of time. And by default, EBS root volumes have delete on termination flag set to true. So if you want to persist your data, then make sure that the flag that you have for delete on termination is set to false. And when it comes to discussing further on the lines of what happens when you are at a stopped state, you can stop an instance that has the EBS volume for its root device, but you cannot stop an instance that has an instance store volume for its root device. That is what we already discussed, isn't it? Because your data will be persisted on the EBS volumes, and if you are using instance store volume, it will not be persisted. Stopping actually causes the instance to stop running. Its status goes from running to stopping to stopped. And a stopped instance persists in Amazon EBS, which allows it to be restarted. So if you have the data, when you restart your instance, your data is still there and you can still make use of it. But you have to understand that stopping is different from terminating. You cannot restart a terminated instance because it is already terminated. Means it is already blown into pieces. It is terminated. You cannot restart that instance because instances with an instance store volume for the root device cannot be stopped. They are either running or terminated. So there are two possible states for that. So if you cannot stop them, then it could either be in a running or terminated state when it comes to instance store volumes. And you might also ask me about the boot times. So instances launched from an Amazon EBS backed AMIs launch faster than instances launched from an instance store backed AMIs. Why is it so? So when you launch an instance from an instance store backed AMI, all the parts have to be retrieved from Amazon S3 before the instance is available. So it might take some time to retrieve the data or the configuration or the template that you have. But with an Amazon EBS backed AMI, only the parts required to boot the instance need to be retrieved from the snapshot before the instance is available. However, the performance of an instance that uses an EBS volume for its root device is slower for a short time, while the remaining parts are retrieved from the snapshot and loaded into the volume within no time at all. And when you stop and restart the instance, it launches quickly because the state is stored in an EBS volume itself. So by this comparison, you obviously know that Amazon EBS backed AMIs launch faster than instance launched from an instance store backed AMI, and restart is also faster. And when it comes to charges, with AMI backed by instance store, you are charged for instance usage and storing your AMI in Amazon S3. With AMI backed by EBS, you are charged for instance usage, EBS volume storage and usage, and storing your AMI as an EBS snapshot. So these things are very important because I don't know, maybe you have used it or you have done this before, but if you have a EBS snapshot and if you're deleting it, and if there is an attached AMI associated to it, you cannot delete that EBS snapshot. And the major impact that you have is with Amazon EC2 instance store backed AMIs. Each time you customize an AMI and create a new one, all of the parts are stored in Amazon S3 for each of the AMIs. So the storage footprint for each customized AMI is the full size of the AMI itself, isn't it? It would be, obviously. And for Amazon EBS backed AMIs, each time you customize an AMI and create a new one, only the changes are stored. So the storage footprint for subsequent AMIs that you customize after the first is much smaller, resulting in lower AMI storage charges when it comes to, obviously, EBS backed AMIs. So the storage footprint is larger in instance store backed AMIs, and it is way less on the side of Amazon EBS backed AMIs. So the charges will be also less. And when an instance with an EBS volume for its root device is stopped, you are not charged for the instance usage. However, you are still charged for volume storage. And as soon as you start your instance, AWS charges a minimum of 1 minute for usage. After 1 minute, AWS charges only for the seconds used. For example, if you are running an instance for 20 seconds and then stop it, AWS will charge for a full 1 minute. And if you run an instance for 3 minutes 40 seconds, AWS will charge for exactly 3 minutes and 40 seconds of usage. So you get the point. So as it is already mentioned, after 1 minute, AWS charges only for the seconds used. But as soon as you start your instance, AWS charges a minimum of 1 minute for usage. And what AWS tells is that they charge for each second with 1 minute minimum, that you keep the instance running even if the instance remains idle and you don't connect to it. So minimum of 1 minute is obviously a better choice. And when it comes to AMIs, the purpose of it is to launch instances, isn't it? But what happens when you launch the instance? There should be some booting that takes place, isn't it? So there are boot modes in AMIs as well. When a computer boots, the first software that it runs is responsible for initializing the platform and providing an interface for the operating system to perform platform specific operations. So it could be different, but they provide the similar features when it comes to Linux and Windows, when it actually starts up and provides the interface for the users to make use of it or make use of the operating system. So the first one that we have here is default boot modes. So in EC2, two variants of the boot mode software are supported. The first one is, I think you would have already heard this, which is Unified Extensible Firmware Interface, that is UEFI, and Legacy BIOS. By default, Graviton instance types run on UEFI, and the Intel and AMD instance types run on Legacy BIOS. So remember, Graviton instance types run on UEFI, that is Unified Extensible Firmware Interface. And Intel and AMD instance types run on Legacy BIOS. But you might ask that, how is it possible? They could also run on these other platforms as well, isn't it? Yes, most Intel and AMD instance types can run on both UEFI and Legacy BIOS. And to use UEFI for Intel and AMD instance types, you must select an AMI with the boot mode parameter set to UEFI. and the operating system contained in the AMI must be configured to support UEFI. So the way to use it is you must select an AMI with the boot mode parameter set to UEFI, and the operating system contained in the AMI must be configured to support UEFI. I hope you got that. But what is the purpose of AMI boot mode parameters? Here, AMI boot parameters signals to EC2 which boot mode to use when launching an instance. When the boot mode parameter is set to UEFI, EC2 attempts to launch the instance on UEFI itself. If the operating system is not configured to support UEFI, the instance launch might be unsuccessful. And what could be the possible boot mode parameters on an AMI? So the AMI boot mode parameters is basically optional, and an AMI can have one of these following boot mode parameter values. That is, one is UEFI or legacy-BIOS. And you would be interested that some AMIs do not have a boot mode parameter. And for those AMIs with no boot mode parameter, the instance launched from these AMIs use the default value of the instance type. That is UEFI on Graviton and legacy BIOS on all Intel and AMD instance types. And when it comes to AMIs, we already discussed that we have two types. Before that, one is the shared AMI and another one is the paid AMI. So as we already spoke about the various types of AMIs, we had in our mind that there are two types of them which are actually available to us. So it could either be customized, which we can keep it separately, but the ones that we want to talk about are shared AMIs and paid AMIs. So a shared AMI is an AMI that a developer created and made available for others to use. One of the easiest ways to get started with Amazon EC2 is to use a shared AMI that has the components you need and add custom content on top of the AMI to create your own. You can also create your own AMIs and share them with others. You use a shared AMI at your own risk because Amazon doesn't vouch for the integrity or security of AMIs shared by other Amazon EC2 users. So use it at your own discretion. Therefore, you should treat shared AMIs as you would any foreign code that you might consider deploying in your own data center and perform the appropriate due diligence. So that's what AWS is trying to tell you, that if that AMI is being provided by some other Amazon EC2 user and not by AWS themselves, then you should treat the shared AMIs as you would any foreign code that you might consider deploying in your own data center. But AWS actually recommends that you get an AMI from a trusted source. What are verified providers then? So in Amazon EC2 console, public AMIs that are owned by Amazon or a verified Amazon provider or partner are marked as verified providers. You can also use the describe-images AWS CLI command to identify the public AMIs that come from a verified provider. And the public images that are owned by Amazon or a verified partner have an aliased owner, which is either Amazon or AWS Marketplace. So when you do the describe images and you see the aliased owner values, it could be either Amazon or AWS Marketplace. In the CLI output, these values appear for image owner alias. So this is the key that you need to find in the output for describe images. And you would say, what happens, like if suppose this is the value that has to be written, then I can also do that. But you have to understand that other users can't use or other users can't alias their AMIs. And therefore, this enables you to easily find AMIs from Amazon or verified partners. So to become a verified provider, what you need to do? So to become a verified provider, you must register as a seller on the AWS Marketplace. Once you are registered, you can list your AMIs on the AWS Marketplace. There is a link already provided in the documentation where we have getting started as a seller and AMI based products. So you can just go there and see the AWS Marketplace seller guide to get more information. The next one is paid AMIs. So what is a paid AMI? So a paid AMI is an AMI that you can purchase from a developer. So a paid AMI is an AMI that you can purchase from a developer. Here Amazon EC2 integrates with AWS Marketplace, enabling the developers to charge other EC2 users or Amazon EC2 users for the use of their AMIs or to provide support for the instances. So when we consider the marketplace or the AWS Marketplace, it is basically an online store where you can buy software that run on AWS, including AMIs that you can use to launch your EC2 instance. Yes, in your marketplace, it behaves like an online store where you can buy softwares that can run on AWS, which includes your AMIs as well that you can use to launch your EC2 instance. The AWS Marketplace AMIs are organized into categories such as developer tools to enable you to find products to suit your requirement. For more information about the AWS Marketplace, you can actually visit AWS Marketplace website to find further details on this. And launching an instance from a paid AMI is the same as launching an instance from any other AMI. So there is no difference at all. No additional parameters are required, and the instance is charged according to the rates set by the owner of the AMI, as well as the standard usage fees for the related web service. For example, the hourly rate for running an M1 small instance type in EC2 will be the same, and additional taxes might also apply. So the owner of the paid AMI can confirm whether a specific instance was launched using that paid AMI. And one more important thing that you have to remember here is Amazon DevPay, which is one of the services from AWS, is no longer accepting new sellers or products. AWS Marketplace is now the single unified e-commerce platform for selling software and services through AWS. So how do we sell your AMIs, or how do you sell your AMIs? So you can sell your AMI using AWS Marketplace. AWS Marketplace offers an organized shopping experience. Additionally, AWS Marketplace also supports AWS features such as Amazon EBS backed AMI, reserved instances, and spot instances. So when we spoke about having a AMI from a trusted source, so how you can find a paid AMI? So there are several ways that you can find AMIs that are available for you to purchase. So first thing you can go to is your Amazon EC2 console or the AWS Marketplace, or you can use the command line as well. Alternatively, a developer might let you know about a paid AMI themselves. So if you know a developer and he owns a paid AMI, and if you want to use it, they can also let you know about the AMI ID so that you can make use of it. So you can go to the Amazon EC2 console, and you have the option on the left hand side for the AMIs. And if you are on the console, then you can just see that you have on the left hand side bar or the navigation bar, you have AMIs. So you can click on that. You can choose public AMIs, and on the search bar, you can choose the owner alias as AWS Marketplace. And if you want to make it simpler, and if you know the product code, you can choose product code. Then you can enter the product code and you can search based on that. So this is basically how you can find a paid AMI using the console. And if suppose you want to find it using the AWS Marketplace, you can go to AWS Marketplace website, enter the name of the operating system in the search field, and then choose the search button. Then what it does, it helps you by scoping the result further, and you can choose one of the categories or filters that you want. And each product is labeled with its product type. So either it could be an AMI or a software as a service. Now, how you can find AMIs or paid AMIs using AWS CLI? So you have AWS CLI options. So where you can type AWS space EC2 space describe hyphen images space hyphen owners space AWS marketplace or AWS hyphen marketplace. So this command returns numerous details that describe each AMI, including the product code for a paid AMI. And the output from describe images includes an entry for the product code. I told you it will have a entry for the product code. So it will be a JSON where the first key would be product code ID and the product code type. And if you already know the product code, you can actually use that as a filter in your first command that we spoke right now. So you can do like AWS space EC2 space describe hyphen images space hyphen owners. So owners will be AWS hyphen marketplace. And the filters that you can use is by using hyphen filters parameter. And in that you can type name equal to product code, values equal to the product code that you know. So the product code will be the key, and the one that you have with you, the product code, will be the value. And before even launching the instance, you must purchase a paid AMI. So you must sign up for a paid AMI before you can launch an instance using that. And typically a seller of a paid AMI presents you with the information about the AMI, including its price and a link where you can buy it. When you click on the link, you are first asked to log into AWS and then you can purchase the AMI. So you might have a doubt, what about paid support? So Amazon EC2 also enables developers to offer support for software that is derived AMIs. So developers actually can create support products that you can sign up to use. During sign up for the support product, the developer gives you a product code, which you must then associate with your own AMI. This enables the developer to confirm that your instance is available for support. It also ensures that when you run instances of the product, you are charged according to the terms of the product specified by the developer. And important thing to note here is you cannot use a support product with reserved instances. You always pay the price itself, or you always pay the price that's specified by the seller of the support product. And at the end of each month, you receive an email with the amount your credit card has been charged for using any paid or supported AMIs during the month. So this bill is separate from your regular Amazon EC2 bills, and you can go to paying your products website in the AWS Marketplace Buyer's Guide to see more about that. The next thing that I wanted to talk about is Amazon Machine Images lifecycle, but we know that the lifecycle for the AMI is straightforward. So you create an AMI, you copy an AMI, you store and restore an AMI, you deprecate an AMI, you actually deregister your AMI as I already told you, and you recover AMIs from the recycle bin and automate the EBS backed AMI lifecycle. So these are some of the lifecycle activities of AMIs. And when it comes to creating an AMI, you can create EBS backed Linux AMIs and instance stored backed AMIs, as we already discussed. And we have different procedure sets for each of them on to how we can actually create them. So you can find more details about how you can create each of them using the website or the documentation provided by AWS. But we'll just look into the more important things that we can actually listen to and learn from. So the next thing that I want to talk about is copy an AMI. So you can copy an Amazon machine image within or across AWS regions. So you can copy an Amazon machine image AMI within or across AWS instances. So within the region also you can copy, and across AWS regions also you can copy. So if suppose you are working in US West 2, then you can copy your AMI within that, or else if you want any person who is working on AP South East or AP Southeast 1 or Southeast 2, then you can also share that AMI by copying that AMI to that other region as well. You can copy both EBS backed AMIs and instance store backed AMIs. And you can copy AMIs with encrypted snapshots and also change encryption status during the copy process. So it's a very important thing. So you can copy AMIs with encrypted snapshots, and also you can change the status of the encryption as well during the copy process. And you can copy AMIs that are shared with you as well. It's not that you can only copy the AMIs that you create. You can also copy the AMIs which are shared with you as well. And copying a source AMI results in an identical but distinct target AMI with its own unique identifier. So you might say that you have just copied it, so it might be identical. But yes, identical does not exactly mean that all the metadata will be same. So that is why it will have its own unique identifier. You can change or deregister the source AMI with no effect on the target AMI. The reverse is also true. So if suppose you created a copy of the AMI and you deleted the original copy, so there is no effect to the copied AMI. And therefore, like if suppose you delete the copied AMI, then there won't be any effect to the original AMI. And then with an Amazon EBS backed AMI, each of its backing snapshots is copied to an identical but distinct target snapshot. So if you copy an AMI to a new region, the snapshots are complete, which means that the snapshot are complete copies, non-incremental. And if you encrypt unencrypted backing snapshots or encrypt them to a new KMS key, the snapshots are complete copies as well. Subsequent copy operations of an AMI results in incremental copies of the backing snapshots. And there are no charges for copying an AMI. However, standard storage charges and data transfer charges apply. So if you copy an EBS backed AMI, you will incur charges for the storage of any additional EBS snapshots. So what are the points that we need to consider when we are copying an AMI? So you can use IAM policies to grant or deny users permissions to copy AMIs. You can have resource level permissions specified for copy image action apply only to a new AMI. You cannot specify resource level permissions for the source AMI. So you need to understand these 3 points. You cannot specify resource level permissions for the source AMI. And AWS does not copy launch permissions, user defined tags, or Amazon S3 bucket permissions from the source AMI to the new AMI. And after the copy operation is complete, you can apply launch permissions, user defined tags, and Amazon S3 bucket permissions to the new AMI. So by default, while copying, it does not do that, but after the copy operation is complete, you can apply the launch permissions, user defined tags, and Amazon S3 bucket permissions to the new AMI that you have created. The third point that you have to understand is if you are using an Amazon Marketplace or AWS Marketplace AMI or an AMI that was directly or indirectly derived from an Amazon Marketplace AMI, you cannot copy it across accounts. Instead, launch an EC2 instance using the AWS Marketplace AMI, then create an AMI from that instance, and then you can proceed further for copying that to other accounts. So how do we store and restore an AMI using S3? So what AWS tells us is that you can store an Amazon machine image or AMI in an Amazon S3 bucket, copy the AMI to another S3 bucket, and then restore it from that particular S3 bucket. So the best way that Amazon tells us is that you can actually just store the AMIs that you have on S3 bucket, copy the AMI to another bucket, and then restore it from the S3 bucket. So by storing and restoring an AMI using S3, you can copy AMIs from one AWS partition to another. For example, the main commercial partition to the AWS GovCloud partition. You can also make archival copies of the AMIs by storing them in an S3 bucket. So these are very important points because you can do a lot when you have the data with you. And the supported APIs for storing and restoring an AMI using S3 are create store image task, describe store image tasks, and create restore image task. And copy image is the recommended API to use for copying AMIs within an AWS partition. However, copy image can't copy an AMI to another partition. So you must understand the limitation and the operations that you can perform using certain APIs. So copy image is a recommended API for copying AMIs within the AWS partition. So previously, actually, we had already discussed like what if we no longer need the AMIs, or what if the AMI should be deprecated. Deprecated in the sense, so in information technology, deprecation means that although something is available or allowed, it is not recommended, or that in the case where something must be used, to say it is deprecated means that its failings are recognized. But you must think that maybe deprecate is similar to delete, but they are two different things. So deprecation and removal are totally different things. They may be similar in some of the aspects in the end result, but they are different things. So deprecation on the one hand actually means that the manufacturer discourages of features use but leaves it available. So let's suppose you have a function in Python which is deprecated. So even though you can make use of it, but Python itself will give you a warning that this function has been deprecated, and it is advised that a more enhanced function is already available in Python that you can make use of instead of that particular deprecated one. And deprecation occurs when a feature is unsafe or gets replaced with a superior alternative. Removed, it's like you just remove it, you just delete it. It's no longer available to you. So I hope you understood the difference between like deprecation and removal or deletion. So when it comes to deprecating an AMI, so you can deprecate an AMI to indicate that it is out of date and should not be used. You can also specify a future deprecation date for an AMI, indicating when the AMI will be out of date. For example, you might deprecate an AMI that is no longer actively maintained, or you might deprecate an AMI that has been superseded by a newer version. So let's suppose you had a AMI with version 1.0 and you have added some of the new features and you released a newer version that is 1.5. So now what happens is, even though the 1.0 version of AMI exists, you would recommend people to make use of the newer version because it has been superseded by the older one. And by default, deprecated AMIs do not appear in AMI listing, preventing new users from using out-of-date AMIs. However, existing users and launch services such as launch templates and auto-scaling groups can continue to use a deprecated AMI because they have the ID itself. So by specifying its ID, launch templates and auto-scaling groups can continue to use a deprecated AMI. And the solution would be to delete the AMI so that users and services cannot use it. And to delete that, you must deregister it. So what happens after an AMI is deprecated? So for AMI users, the deprecated AMI does not appear in describe images API calls unless you specify its ID or specify that deprecated AMIs must appear in the output. And AMI owners continue to see the deprecated AMIs in describe images API calls. For AMI users, the deprecated AMI is not available to select via the EC2 console. For example, a deprecated AMI does not appear in AMI catalog in the launch instance wizard. But on the other hand, for the AMI owners itself, you continue to see the deprecated AMIs in the EC2 console because you are the owner. So for AMI users, if you know the ID of a deprecated AMI, you can continue to launch the instance using that deprecated AMI using API, CLI or SDKs. And launch services such as launch templates, auto scaling groups can continue to reference the deprecated AMI. as I already told you, because they are launched or they have that configuration of the older specified AMI ID. And EC2 instances that were launched using the AMI that is subsequently deprecated are not affected. I already told you, like even if you delete the AMI, the existing launched EC2 instances will have no effect. And they can be stopped, started, and rebooted as well. And you can deprecate both private and public AMIs. And moreover, for the benefit of the users and the owners, you can also create Amazon Data Lifecycle Managed EBS backed AMI policies to automate the deprecation of EBS backed AMIs. And furthermore, on these lines, AWS has released a new feature where by default, the deprecation date of all public AMIs is set to 2 years from the AMI creation date. So it's interesting, isn't it? So by default, the deprecation date for all public AMIs is set to 2 years from the AMI creation date. Initially, all public AMIs that are older than 2 years will be deprecated on July 30th, 2022. So it has already passed. And you can set the deprecation date to earlier than 2 years as well. And you can also cancel the deprecation date, or even to move to the deprecation date to a later date, you must make the AMI private by only sharing it with specific AWS accounts. So if you make it private, you have more control over the deprecation date, or if you want, you can move it to a later date for your deprecation. But if it's a public AMI, then by AWS itself, it is set to 2 years from the AMI creation date. So is there any cost or limitation to deprecate an AMI? So when you deprecate an AMI, the AMI is not deleted. I already told you, deletion and deprecation is different. So when you deprecate an AMI, the AMI is not deleted. And the AMI owner continues to pay for the AMI's snapshot. So to stop paying for the snapshot, the AMI owner must delete the AMI by deregistering it. And what are the limitations? The only limitation could be to deprecate an AMI, you must be the owner of the AMI. So if you are the owner of the AMI, you can deprecate the AMI itself. Now that we spoke about how we can deprecate the AMI, let's go on to the next one, that is deregister your AMI, that is delete your AMI. So you can you can deregister an AMI when you have finished using it. After you deregister an AMI, you can't use to launch new instances. So that's the biggest difference. So once you deregister an AMI, you can no longer use it to launch new instances. And when you deregister an AMI, it doesn't affect any instances that you have already launched from the AMI or any snapshots created during the AMI creation process. So that's a good part, isn't it? Even if you accidentally deleted the AMI, you can create more from the existing instance, but that's the beauty of it, because even if the instances are running and you delete the AMI, it does not get affected. That comes with a cost as well, that you will continue to incur usage cost for these instances and storage costs for the snapshot. Therefore, you should terminate any instance and delete any snapshots that you are finished with. And just like you have creation process for AMIs, which are different for Amazon EBS backed AMIs and instance store backed AMIs, the cleanup process for them are also different. So you must consider them before moving forward. So you can actually determine the root device type for your AMI, and you can choose which option of cleanup that you want to proceed further with. So are there any considerations that we have to make before or when you apply deregistering an AMI? So first thing is, you cannot deregister an AMI that is not owned by your account. So if the AMI that you have is not owned by your account, then you cannot deregister it. And you cannot deregister an AMI that is managed by the AWS backup service using Amazon EC2. Instead, we can make use of Amazon backup to delete the corresponding recovery points in the backup vault. So that is something that you need to remember. You cannot deregister an AMI that is managed by the AWS backup service using Amazon EC2. So now that we have discussed about deprecating an AMI and deregistering an AMI, Let's see how we can recover AMIs from the recycle bin. So recycle bin is a data recovery feature that enables you to restore accidentally deleted Amazon EBS snapshots and EBS backed AMIs. When using recycle bin, if your resources are deleted, they are retained in the recycle bin for a time period that you specify before being permanently deleted. So that's a very good feature, isn't it? So you have a recycle bin that acts as a data recovery feature that enables you to restore accidentally deleted Amazon EBS snapshots and EBS backed AMIs. And here you can restore a resource from the recycle bin at any point or any time before its retention period expires. And after you restore a resource from the recycle bin, the resource is removed from the recycle bin and you can use it in the same way that you use any other resource of that type in your account. And what happens if the retention period expires? So if the retention period expires and the resource is not restored, the resource is permanently deleted from the recycle bin and it is no longer available for recovery. I hope you got the point. So if the retention period expires and the resource is not restored, then the resource is permanently deleted. So it's gone. And it is gone from the recycle bin and it is no longer available for discovery or recovery. So as it is no longer available for recovery, you cannot recover it and you cannot use it. And AMIs in the recycle bin do not incur any additional charges. So most of the times you won't hear about this recycle bin feature in AWS. So now what we can talk about is encryption with EBS backed AMIs. So data security and protection is also important. So AMIs that are backed by Amazon EBS snapshots can take advantage of Amazon EBS encryption. I already told you that AMIs that are backed by EBS snapshots are very well enough to take advantage of the Amazon EBS encryption. So snapshots of both data and root volumes can be encrypted and attached to an AMI. You can launch instances and copy images with full EBS encryption support, and encryption parameters for these operations are supported in all regions where KMS is available or key management service is available. And when it comes to EC2 instances with encrypted EBS volumes, so EC2 instances with encrypted EBS volumes are launched from AMIs in the same way as other instances. And in addition, when you launch an instance from an AMI backed by unencrypted EBS snapshot, you can encrypt some or all of the volumes during launch. And like EBS volumes, snapshots in AMIs can be encrypted by either your default AWS KMS key or to a customer managed key that you specify. But to do that, you must have the permissions to use the selected KMS keys. And AMIs with encrypted snapshots can be shared across AWS accounts. And as I already told you, you must have the keys to make use of them. Now let's talk about how we can monitor the AMI events using Amazon Event Bridge. So every resource that you create must go through a phase where it will change its state. So similarly, AMIs also have that. So when the change of an when the state of an Amazon machine AMI so when the state of an Amazon machine AMI so when the state of an Amazon machine image or AMI changes, Amazon EC2 generates an event that is sent to Amazon Event Bridge, which was formerly known as CloudWatch events. And you can use Amazon Event Bridge to detect and react to these events. And you do this by creating rules in Event Bridge that trigger an action in the response to an event. So let's suppose there is an event that gets sent, and based on that particular event, you can actually create rules to trigger an action based on what action that you want to perform if that particular type of event comes to the Event Bridge. For example, you can create an event bridge rule that detects when the AMI process or the creation process is completed and then invokes an Amazon SNS topic to send an email notification to you. So what if you want an email notification when your automated AMI creation process is completed? So once it is completed, then you can have the status being sent to event bridge, and upon that you can add a trigger point where you can associate a SNS topic so that it can send an email notification to you. And Amazon EC2 generates an event when an AMI enters in any of the following states. So it could be either available, it could be in a state of failed, or it could be in deregistered. And an AMI can enter the available or failed state when you perform the operations such as create image, copy image, register image, create restore image task. So available or failed state can be seen when these operations are performed. So create image, copy image, register image, create restore image task. So these are the 4 operations. And an AMI can enter the deregistered state obviously when you perform the deregister image operation. And you can ask me like what exactly would happen in a particular state. Let's suppose we take the example of available. So the AMI enters the available state when it actually completes a successful create image, copy image, register image, or create restore image task operation. So if these operations are successful, then the state of that particular AMI will be available. And on the other hand, similarly, vice versa, if these operations such as create image, copy image, register image, or create restore image task operations fails, then the AMI enters the failed state. But here you have a key that you will see that is state, that is basically failed, obviously. And you have an error message field as well, which can provide the reason of why the operation actually failed. So along with state, you have error message. So based on that, you can find out what exactly went wrong. So error message can actually help you. It provides the description of the failure. And as we already know that when the AMI actually enters the deregistered state, it actually follows a successful deregistered image operation. Now let's come back to one of the most important topics, that is Amazon EC2 instances. So we discussed about the images. Now we will discuss about the Amazon EC2 instances. So whenever you are working in a production environment, before you launch a production environment, you need to answer the following questions. So the first question would be, what instance type best meets my needs? Yes, you would use the things that are actually in line and make sense for your business requirements and needs. So Amazon EC2 provides different instance types to enable you to choose the CPU, memory, storage, and networking capacity that you need to run your application. So based on that, you can select the one that best suits your requirement. The second question would be, what purchase options best meet my needs? So Amazon EC2 supports on-demand instances, which is the default, spot instances, and reserved instances. So I think most of you actually know the differences between them, but we will discuss anyways. But you have to select on what basis you want your instances to be launched. So do you want it to be launched on demand? So basically, if you want to schedule it, or if you want to launch it on your own, then you can go for the on-demand instances. Spot instances are similar, but they are available at a spot at a cheaper price, but they can easily be taken over by someone else who bids a higher price. And reserved instances are like you reserve it for a particular time period and you are charged for that. The third one is, which type of root volume meets my need? So root volume is very important. We already discussed about instance stores and EBS backed volumes. So each instance is backed by Amazon EBS, or it could be backed by instance store. So we can select an AMI based on which type of root volumes we need. And the last one is, can I remotely manage a fleet of EC2 instances and machines in my hybrid work environment? That could be also an option, isn't it? If suppose you work in a hybrid model and you would want to manage your EC2 instances remotely, so can you do that? Yes, AWS System Manager actually enables you to remotely and securely manage the configuration of your Amazon EC2 instances and your on-premise instances and virtual machines in a hybrid environment, including VMs from other and the best part is it includes VMs from other cloud providers as well. So if you want to learn more about that, you can just go to AWS System Manager and you can read more about that and how we can manage a fleet of instances and machines in the hybrid environment. So now some of you might have a doubt between what is the difference between instances and AMIs. So remember that an AMI is a template, or the AMI, or what we call as Amazon machine image, is a AMI, and it is a template that contains a software configuration. For example, an operating system, an application server, and applications. And from an AMI, you launch an instance, which is a copy of the AMI running as a virtual server in the cloud. So you launch an instance from the AMI, and AMI is just a template that contains a software configuration. And you can launch multiple instances from the same AMIs as well. Or you can have multiple AMIs with multiple configurations and you can launch instances from them as well. And the instances that you have, they will keep running until you stop them, hibernate them, or terminate them, or until they fail on their own. And if an instance fails, you can launch a new one from the AMI. And if you've automated the process, the auto scaling group would actually do that for you. So what is an instance? So an instance is a virtual server in the cloud. Its configuration at launch is a copy of the AMI that you specified when you launched the instance. So the AMI basically decides what the configuration should be for the instance that has been launched. And you can launch different type of instances from a single AMI, and an instance type essentially determines the hardware of the host computer used for your instance. And here you don't have to confuse between an instance and an instance type. So instance is basically the virtual server, but the instance type determines the hardware of the host computer used for your instance. So each instance type offers different compute and memory capabilities. And you must select an instance type based on the amount of memory and computing power that you need for the application or software that you plan to run on the instance. And that is why, based on your requirement, you have to choose a particular type of EC2 instance type. And after you launch an instance, it looks like a traditional host, and you can interact with it as you would with any other server, a Linux server or the Windows server that you have launched, and you have complete control of your instance. And you can use sudo to run commands that require root privileges. Your AWS account that you have has a limit on the number of instances that you can have running, and you can actually increase the limit, and how you can actually increase the limit will be considered. And limit increases are tied to the region they are requested for. So based on the region also it may vary, but if you want to increase your limit, then you have to fill the request form for Amazon EC2 limit increase. And you might ask me, like, how many instances can I run in EC2 or Amazon EC2? So you're limited to running on-demand instances per your VP. And new AWS accounts may start with limits that are lower than the limits described in the documentation. So you must actually go through the documentation or the support to actually find out what exactly should be the number of instances that you can launch and what could be the limit. And if you want to increase them, you can actually fill the form for the Amazon EC2 limit increase. And what about the storage of your instance? So the root device for your instance contains the image used to boot the instance. So basically, like, it would be the root device where actually you have the image which actually is used to boot the instance itself. And the root device is either an Amazon Elastic Block Store volume or an instance store volume, which we have already discussed in length. Your instance may include local storage volumes known as instance store volumes, which you can configure at launch time with block device mapping. And after these volumes have been added and mapped onto your instance, they're available to you to mount and use. And if your instance fails, or if your instance is stopped or terminated, the data on these volumes is lost. Therefore, these volumes are best used for temporary data. So to keep important data safe, you should use a replication strategy across multiple instances and store your persistent data in Amazon S3 or Amazon EBS volumes. So that's something that we already know, and that's the best way forward. Now, when it comes to security best practices for your EC2 instances, AWS recommends that you use AWS Identity and Access Management or IAM to control access to your AWS resources, including your instances. And you can create IAM users and groups under your AWS account, assign security credentials to each, and control the access that each has to the resources and services in AWS. And you can also restrict access by only allowing trusted hosts or networks to access ports on your instance. For example, you can restrict SSH access by restricting incoming traffic on port 22. So security groups are really important. So now what you can do is you can review the rules in your security groups regularly and ensure that you apply the principle of least privilege. So let's suppose an instance actually needs users to have access for only SSH. So you can allow port 22, but what if that is the only purpose? But sometimes what we do is we allow HTTP or HTTPS, which is not required. So only allow the things that you need. And that is what is basically known as the principle of least privilege. So what it says is only open up permissions that you require. And you can also create different security groups to deal with instances that have different security requirements. So let's suppose some other instance needs port 80. Then create a different security group for that. You don't have to create one, and it's not mandatory to be used by all the instances. You can create your security groups. For example, when we talk about Bastion hosts, we can actually create a security group that allows external logins to that particular Bastion. But we can keep the remainder of our instances in a group or security group that does not allow external logins. The only way for people to actually make use of the instances is through the Bastion host. And the most important part is disable password-based logins for instances launched from your AMIs. Because passwords can be found or cracked and are a security risk. So please make sure that you disable password-based logins for instances launched from the AMI. We already spoke about deprecating and deleting or deregistering AMIs. Now let's talk about stopping and terminating instances. So how many of you feel that stopping or terminating are the same thing? So I feel that I think very few of you might be having that thought in your mind, but they are obviously different, and you can stop or terminate a running instance at any given point of time. So what happens when you stop an instance? So in AWS, when an instance is stopped, the instance performs a normal shutdown and then transitions to a stopped state. All of its Amazon EBS volumes remain attached, and you can start the instance again at a later time. It's just like shutting down your computer. You start it again, everything resumes to the normal state. And you're not charged for additional instance usage while the instance is in a stopped state. So that's a very good thing. And a minimum of 1 minute is charged for every transaction from a stopped state to a running state. We already discussed this point, like minimum of 1 minute means like if suppose you have an instance that is in the stopped state and you started it and you used it for 20 seconds or 30 seconds or 50 seconds below 1 minute, then the whole 1 minute will be charged. And after that, it will be per second basis. And one more thing that is really interesting is if the instance type was changed, like if you had t2.micro and you increased it to c4.large or r5.large or something like that, and the instance type was changed while the instance was stopped, you will be charged the rate for the new instance type after the instance is started, not when you actually change it. So even if you changed it and the instance is stopped, then also there will be no impact, but when you start it, it will be charged for the new instance type. And all of the associated EBS usage for your instance, including root device usage, is billed using typical Amazon EBS prices. And when an instance is in a stopped state, you can attach or detach Amazon EBS volumes. You can also create an AMI from the instance, and you can change the kernel, RAM disk, and instance type as well. So it's a good thing. So even when your instance is at a stop state, or when your instance is in a stop state, you can change the kernel, RAM disk, and instance type. So because most of the time, these operations won't be possible while the instance is in a running state. Now let's talk about the termination of the instance. We already spoke about the stopping of the instance, and now let's talk about the termination of the instance. So when an instance is terminated, the instance performs a normal shutdown, similar to what we have in stop. And the difference here is the root device volume is deleted by default, but any attached Amazon EBS volumes are preserved by default, determining by each volume's delete on termination attribute setting. So as I already told you, if you want to have your Amazon EBS volumes intact even after termination of your instance, and for that the attribute settings for each of the volumes delete on termination should be set to false. So it will not be deleted on the instance termination. The instance itself is also deleted, and you cannot start the instance again at a later time. So once your instance is terminated, you cannot perform a restart there. You have to just think that it is terminated, and you can just launch a new instance using the AMI that you had used to launch this particular instance that you terminated. To prevent accidental termination, you can disable instance termination. So that's a good part. So you can prevent accidental termination. So to do that, you can actually disable instance termination. But if you do so, ensure that the disable API termination attribute is set to true for the instance. And to control the behavior of an instance shutdown, such as shutdown-h in Linux or shutdown in Windows, set the instance initiated shutdown behavior instance attribute to stop or terminate as desired. So we can control the behavior, like if suppose you want to shut down from Linux itself, like shutdown-h, you have the commands, isn't it? And in Windows as well. So for that, you need to set the instance initiated shutdown behavior instance attribute to stop or terminate based on what you actually want. So what would you want when you type in the command shutdown-h? So you can set it to either stop, or it can be used as terminate as well. So based on that, you can set the permissions for these commands using instance initiated shutdown behavior. So because it is instance initiated, because within the instance it is trying to perform the operation. And instances with Amazon EBS volumes And instances with Amazon EBS volumes for the root device actually default to stop. And on the other hand, the instances with instance store root devices are always terminated as the result of an instance shutdown. So for Amazon EBS volumes, the root device default is to stop, and for instance store root devices, it is always terminated. I hope you remember the point. So now that we have spoken about instances and AMIs, let's talk about the instance types. So when you launch an instance, the instance type that you specify determines the hardware of the host computer used for your instance. So each instance type offers different compute, memory, and storage capabilities and is grouped in an instance family based on these capabilities. So the only thing that you need to do is select an instance type based on the requirements that you have for your application or software that you plan to run on your instance. So if you have a application that is memory intensive, then you would choose something that could help on those lines. Let's suppose you have something that is compute intensive, then you would choose something that can help you with the computation. Let's suppose you have something that is graphic intensive, then you have instance types for that as well, where you can use them or you can choose them for your instance type and the requirement that you have. And AWS makes it easy because Amazon EC2 provides a variety of instance types, so you can choose the type that best meets your requirement. And instance types are named based on their generation, family, and additional capabilities, and the size as well. So you have like large, medium, small, and the first position indicates the instance family. So let's suppose we have C5D.9x large. Remember C5D.9x large. Then the C that you have of the C5D, the C is the instance family. So the first position indicates the instance family. For example, when I say C5D.9x large, it is C is the instance family. The second position indicates the instance generation. So in C5D, the 5 is the instance generation, or it could also be called as the 5th generation. And the remaining letters before the period indicate additional capabilities such as local NVMe storage and full control over C states. So the D that you have is basically your additional capabilities. So in C5D.9x large, if you take C5D, then C is the instance family, 5 is the instance generation, and D is the additional capability. And after the period, you have the instance size, which is either a number followed by a size such as 9x large. For metal instances, the word metal. So the whole thing comprises of the instance family, instance type, instance generation, additional capabilities, and all together it forms the instance type. So that is how the naming convention is. And the benefits of using Amazon EC2 is that it provides each instance with a consistent and predictable amount of CPU capacity, regardless of its underlying hardware. And it dedicates some resources of the host computer, such as CPU, memory, instance store, to a particular instance. And Amazon EC2 shares other resources of the host computer, such as network and disk subsystem, among instances. So EC2, when you think of, so the CPU, memory, and instance storage will be assigned to allocated to a particular instance, but when you think of the resources for a host computer, such as the network or the disk subsystem, it will be shared among the instances. If each instance on a host computer tries to use as much of one of these shared resources as possible, each receives an equal share of that resource. So it's a good thing. However, when a resource is underused, an instance can consume a higher share of that resource while it is available. So let's suppose you have 5. Then if suppose among them one of them is underused, then the other instance can make use of the higher share of that resource while it is available. And each instance type provides higher or lower minimum performance from a shared resource. So for example, like if you have instance type with the high IO performance, as we all know that instance types with higher IO performance will obviously have a larger allocation of shared resources. And allocating a large share of shared resources also reduces the variance of IO performance. For most applications, moderate IO performance is more than enough. However, for applications that require greater or more consistent IO performance, we need to consider an instance type with the higher IO performance. So if you need greater and more consistent IO performance, then you should choose an instance type which can provide you that. So there is a wide range or wide selection of instance types optimized for your use cases, and they are available to you at Amazon EC2. And to determine which instance type meets your requirement, so you must consider them like which region they belong to, what are the compute resources, and what are the storage resources. And as I already mentioned, that Amazon EC2 provides a wide selection of instance types optimized to fit different use cases. And the instance types comprise varying combination of CPU, memory, storage, and networking capacity, and give you the flexibility to choose the appropriate mix of resources for your application. And each instance type includes one or more instance sizes, allowing you to scale your resources to the requirements of your target workload. So in Amazon EC2, the instance type could be a general purpose, or it could be compute optimized, it could be memory optimized, it could be accelerated computing. And the last one that we have here is storage optimized. So the first one that we have is the general purpose instances. So general purpose instances provide a balance of compute, memory, and networking resources and can be used for a variety of diverse workloads. These instances are ideal for applications that use resources in equal proportion, such as web servers and code repositories. So most importantly, for us developers, we tend to go towards general purpose. So we now move on to the next important topic, that is instance purchasing options. So AWS actually provides various purchasing options for you to optimize your cost based on your needs. So we have on-demand instances. So pay by the second for the instance that you launch. So you pay for what you use. We have savings plan, so which helps us to reduce our EC2 cost by making a commitment to a consistent usage or amount of usage, which could be in US dollars per hour for a term of over 1 to 3 years. So that is basically a savings plan. You actually plan for a longer period of time and you commit for a consistent amount of usage. We have reserved instances, so you can actually reduce your EC2 cost by making a commitment to a consistent instance configuration, including instance type and region, for a term of 1 or 3 years. And also you have spot instances. So these are very tricky ones. So spot instance actually helps you request unused EC2 instances, which can reduce our Amazon EC2 cost significantly. But there is a bidding system in place for getting the spot instance. So whoever has his bid passed, they get the EC2 instance in place for them to use. Mostly they are used for batch processing and jobs that don't require physical storage, or you don't care about the data if it gets lost. So the next one is dedicated hosts. So you pay for a physical host that is fully dedicated to running your instance, and bring your existing per socket, per core, or per VM software license to reduce cost. So you have a dedicated host for yourself. Now, as we have dedicated hosts, we also have dedicated instances. So here what you do is you pay by the hour for instances that run on a single tenant hardware. So it is dedicated for you. So you have a dedicated instance and you can use that and pay by the hour. And the last one that we have here is capacity reservation. So you reserve capacity for your EC2 instances in a specific availability zone for any duration. So if you require a capacity reservation, we can actually purchase reserved instances or capacity reservation for a specific availability zone. And moreover, when you think of all these saving plans or purchase options, spot instances are a cost effective choice if you can be flexible about when your application runs and if they can be interrupted. So you just want to perform an operation and just leave the instance. You don't need that anymore. So you can use that type of spot instances. And dedicated host or dedicated instances can help you address compliance requirement and reduce cost by using an existing server bound software license. So these are basically dependent on your usage type. So when we talk about the instance purchasing option, the first one let's talk about is the on-demand instances. So with on-demand instances, you pay for compute capacity by the second with no long-term commitments. You have full control over its life cycle. So you decide when to launch, stop, hibernate, start, reboot, or terminate it. So you have full control over its life cycle. And there is no long-term commitment required when you purchase an on-demand instance. You pay only for the second that you use it. So you pay only for the seconds that your on-demand instance are in the running state with a minimum 60-second runtime. So as I already told you, let's suppose you have started the instance, and if you have run for 10 seconds and you shut it down, it will count as 1 minute itself or 60 seconds itself. For the price per second for a running on-demand instance is fixed, and you can check out the pricing details, the documentation as well. And when should we recommend people for using on-demand instances? So AWS tells us that you can or you must use, or it is recommended for you to use the on-demand instances for applications with short-term irregular workloads that cannot be interrupted. So if it is for a short term and it has irregular workloads and which should not be interrupted, so in these cases you can actually use on-demand instances. And if you want to save, so if you want to have an option that helps you save other than the on-demand instances, you can use the AWS savings plan. You have the spot instances or reserved instances as well. And when it comes to the instance limit, so there is a limit on the number of running on-demand instances per AWS account per region. And on-demand instance limits are managed in terms of the number of virtual central processing units or vCPUs that your running on-demand instance are using. That is regardless of the instance type. And there are 8 on-demand instance limits, which is basically running on-demand standard, A, C, D, H, I, M, R, T, Z instances. There is for DL instances, there is F instances. So there's a lot of ways or types of on-demand instances limits that AWS sets, so you can basically check them out. And you don't need to worry about what type of instance that you can have with what type of requirements. So you can launch any combination of instance types that meets your changing application need, as long as the number of vCPUs don't exceed your account limit. So for example, with a standard instance limit of 256 vCPUs, you can launch 32 M5.2x large instances, which has around 32 into 8 vCPUs, or 16 C5.4x large instances, so which is around 16 into 16 vCPUs. Now when moving to the reserved instances, so reserved instances provide you with specific or significant savings on your AWS account or AWS EC2 cost compared to the on-demand instance pricing. And reserved instances are not physical instances, but rather a billing discount applied to a use of on-demand instances in your account. So these on-demand instances must match certain attributes such as instant type and region in order to benefit from the billing discount. So savings plan also offers significant savings on your AWS EC2 cost compared to on-demand instance pricing. And why is it that? So basically what happens in saving plans is you make a commitment to a consistent usage amount measured in US dollar per hour. This provides you with the flexibility to use the instance configurations that best meet your needs and continue to save money instead of making a commitment to a specific instance configuration. So you don't have to do that. If you want to use it for a longer period of time, then you can just have a commitment with the savings plan for a consistent usage measured in US dollar per hour. And based on that, you save a lot of money with that rather than using the on-demand instances. And you can purchase a reserved instance for a 1 year or 3 year commitment, with the 3 year commitment offering a bigger discount. So let's suppose you're working in a very large organization. So it would be better for you to have a reserved instances with a commitment time, because you know that these products will be running for a longer period of time. So it's better to use a reserved instance so that you can save a lot of money in the longer run. So 1 year, a year is defined as 31536,000 seconds, that is 365 days, and 3 years is the multiple of what I just said, so 1095 days. And reserved instances do not renew automatically, so that's something that you have to understand. So reserved instances do not renew automatically. When they expire, you can continue using the EC2 instance without interruption, but you are charged on demand rates. So once it is expired, it comes back to the on demand pricing rate. So you just remember that once it is expired, it won't renew automatically and you will not know it, but you have to understand they will be charged based on the on demand rates. And there are multiple payment options also available for you on the reserved instances that are like all upfront. So you can do a full payment, which is made at the start of the term with no additional cost or additional hourly charges incurred for the remainder of the term, regardless of the hours used. So you can use it like every day, every single second, but you'll not be charged anything extra. So you pay the full amount. And there is partial upfront. So in partial upfront, what happens is a portion of the cost must be paid upfront. So you pay a portion of it upfront, and the remaining hours in the term are billed at the discounted hourly rates, regardless of whether the reserved instance is being used or not. So in partial upfront, as the name suggests, you pay partial amount of cost upfront itself, and the remaining hours in the term are billed at the discounted hourly rate. No upfront. So in this case, what happens? You are billed a discounted hourly rate for every hour within the term, regardless of whether the reserved instance is being used or not, and you don't have any upfront cost. So even though you don't pay it, but there will be a discounted hourly rate for every hour that you use in that term of like 1 year or 3 years, and the payment should be made after that. And one thing that you have to remember here is, with no upfront reserved instances, they are based on a contractual obligation to pay monthly for the entire term of the reservation. For this reason, a successful billing history is required before you can purchase no upfront reserved instances. So it's like banks. You should have a very good CIBIL score before the bank actually gives you loans. So this is something that is really interesting. And generally speaking, you can save more money making a higher upfront payment for reserved instances. And you can also find reserved instances offered by third-party sellers at lower prices and short-term lengths on the reserved instance marketplace. So there is a marketplace for reserved instances. You can check them out, and you can sell your instances as well. So that's something that is very good. And sometimes what happens is our requirements might change. So if your computing needs change, you might be able to modify or exchange your reserved instances depending on the offering class. So in that, we have two types of offering classes. So one is standard. So these provide the most significant discount, but can only be modified. And standard reserved instances can't be exchanged. So it cannot exchange it, but it can be modified. And the other one is convertible. So these provide a lower discount than the standard reserved instances, or the instances that are in the standard one. But these, on the other hand, can be exchanged for another convertible reserved instance with different instance attributes. And if it can be exchanged, here as well, you can modify this. So convertible reserved instances can also be modified. Okay, so standard can only be modified, cannot be exchanged, but convertibles can be exchanged with for another convertible reserved instance with different instance attribute. But convertible reserved instance can also be modified, so you get the benefit of both. And one thing you have to remember is that after you purchase a reserved instance, you cannot cancel your purchase. However, you might be able to modify, exchange, or sell your reserved instance if your needs change. So this is something that you have to remember. So after you purchase a reserved instance, you cannot cancel your purchase. However, you can modify, exchange, or sell. So as I already told you that reserved instances are not physical instances, but rather a billing discount that is applied to the running on-demand instances in your account. So here the on-demand instances must meet certain specifications of the reserved instances in order to benefit from the billing discount. So if you purchase a reserved instance and you are already have a running on-demand instance that matches the specification of the reserved instance, the billing discount is applied automatically and immediately. So you don't have to worry about that, and you don't need to even restart your instances. So if you do not have an eligible running on-demand instance, launch an on-demand instance with the same specification as your reserved instance, and thus it will be applied. The next one that we have here is scheduled reserved instances. So with scheduled reserved instances, you can reserve capacity that is scheduled to recur daily, weekly, or monthly with a specific time or start time and duration for a 1-year term. After you complete your purchase, the instances are available to launch during the time frame or the time window that you specified. Let's suppose you want to have an instance that you want to run exactly at 8 a.m. every day for around 2 hours to perform some operation, some job. You can do that. And let's suppose you want to have the saving plan with yourself, like the reserved instances, then you can reserve it for like 1 year or 3 years. And that actually serves a very good use case when you are talking about performing certain operations for a particular period of time and within a specific timestamp or time frame. So one thing that you have to remember is you cannot purchase scheduled reserved instances at this time. AWS does not have capacity available for scheduled reserved instances or any plans to make it available in the future. So this is something of a bad news, I would say, for someone who was actually trying to experiment on this. But in order to do that, or in order to reserve capacity, you can just use your on-demand capacity reservations. And for discounted rates, you can just check out the saving plans. Next one is the very interesting one, which we have is the spot instances. So a spot instance is an instance that uses spare EC2 capacity that is available for less than the on-demand price, because spot instances enable you to request unused EC2 instances at steep discounts. And you can lower your Amazon EC2 cost significantly. So it's a very good option. But let's see what exactly it offers. So the hourly price for a spot instance is called a spot price. Why is it called a spot price? Let's see. So the spot price of each instance type in each availability zone is set by the Amazon EC2 and is adjusted gradually based on the long-term supply of and demand for that spot instance. So you must remember your spot instance runs whenever capacity is available. So how is it that it could be available? So the first thing that you have to understand is spot instances are a cost-effective choice if you can be flexible about when your application runs and if your applications can be interrupted. So for example, spot instances are well suited for data analysis, batch processing or batch jobs or background processing and optional tasks. So these are some of the operations that don't get affected with instances getting shut down. So basically, if you are having like 100 operations that you want to perform, and let's suppose in one cycle of spot instance you are able to manage 10, then it doesn't affect whether the 90 are processed or not, because you wanted the 10 jobs to be processed at once. So, or like in a cycle you were able to perform those 10 jobs, and the rest can perform in other spot instances, so it does not affect you. So that is why it is a very good use case when it comes to using the batch jobs. So there are a few concepts that you need to understand about the spot instances. So one is the spot capacity pool. So spot capacity pool is basically a set of unused EC2 instances with the same instance type and availability zone, which you are working right now. And spot price, as I already told you, the current price of a spot instance per hour. And the next one is spot instance request. So when a capacity is available, that is when we can get the EC2 instance, and that is what AWS tells us. So when you request a spot instance, when the capacity is available, Amazon EC2 fulfills your request. So a spot instance request is either one time or persistent, and EC2 automatically resubmits a persistent spot instance request after the spot instance association with the request is interrupted. So what happens is, it don't have to worry about that. If you're using a persistent spot instance, then EC2 automatically resubmits a request after the spot instance associated with the request is interrupted. The next one that we have here is EC2 instance rebalance recommendation. So what is rebalance recommendation? So what AWS tells us is that Amazon EC2 emits an instance rebalance recommendation signal to notify you that a spot instance is at an elevated risk of interruption. So it is telling you that this might go at any point of time. So this signal provides an opportunity to proactively rebalance your workload across existing or new spot instances without having to wait for the 2-minute spot instance interruption notice. So it is a very good thing that AWS tells you that if instance is about to get revoked, then you have the time to plan it ahead of time. So you have the chance to plan it ahead of time so that you can rebalance your workloads across existing or new spot instances. Otherwise, you have to wait for a 2-minute spot instance interruption notice. The next one, as I already told you, like spot interruption notice. So let's talk about it. So Amazon EC2 terminates, stops, or hibernates your spot instance when Amazon EC2 needs the capacity back. So that is what happens when the spot instance gets terminated. So either it terminates, stops, or hibernates. So Amazon EC2 provides a spot instance interruption notice, which gives you the instance, or which gives the instance a 2-minute warning before it is interrupted. So here what happens is, if suppose an instance is going to be terminated, then AWS tells you or sends a signal that based on what exactly you have to plan. So if suppose your instance is going to be terminated, then as I already told you, we have EC2 instance rebalance recommendation. So EC2 will emit an instance rebalance recommendation signal, notify you that the spot instance is an elevated risk of interruption. And once it is interrupted, or once it is going to be terminated, it'll give you a 2-minute warning before it actually interrupts it or terminates it. But what are the difference between spot instances and on-demand instances? So the spot instances can be launched immediately if the spot instance request is active and the capacity is available. But in on-demand instance, they can only be launched immediately if you make a manual launch request and the capacity is available. And available capacity for the spot instance depends on if the capacity is not available, the spot instance request continues to automatically make the launch request until capacity becomes available. So it will keep on making the launch request until that capacity is available. So you have to wait for that. But on demand side, if the capacity is not available when you make a launch request, you get an insufficient capacity error, ICE. But on the spot instance side, you won't get that. And when it comes to the hourly price for spot instance varies based on long-term supply and demand, and on-demand prices are already defined, they're static. Here, as I already told you, there is the instance interruption. So you can stop and start an Amazon backed EBS snapshot In addition, EC2 can interrupt an individual spot instance if the capacity is no longer available. But you determine when an on-demand instance is interrupted. So it is basically based on what exactly you're doing. An on-demand instance can be stopped by yourself. So you can do that manually or you can do that automatically, but that depends on you. But on spot instance side, AWS decides like whether the instance should be interrupted or not. You can also do that, but I'm saying it generally depends on that on AWS side itself. And there is a rebalance recommendation that I told you for spot instances. So the signal that Amazon EC2 emits for a running spot instance when the instance is is at an elevated risk of interruption. So once you get the signal, you know what to do, and you can plan things before that as well. But on the on-demand side, you determine when an on-demand instance is going to be interrupted, so or it is going to be interrupted. So like we have stopped, hibernated, or terminated. These states are dependent on what action you perform on the on-demand side. And let's look at some of the best practices for EC2 spot. So as I already told you that EC2 spot a spare EC2 compute capacity in the AWS cloud that are available to you at savings of up to 90% compared to the on-demand prices. So it's a very, very cost-effective measure, but it comes with its own risk. So the only difference between on-demand instances and spot instances is that the spot instance can be interrupted by EC2 with 2 minutes of notification when EC2 needs the capacity back. So that's a very big difference, but that could be the deciding factor between what exactly your requirement is. And spot instances are recommended for stateless, fault tolerant, flexible applications. For example, spot instances work well for big data, containerized workloads, CI/CD, stateless web servers, high performance computing, and rendering works. And while running spot instances, so they are exactly the same as on-demand instances, but you have to consider a few points here. Like the spot instance does not guarantee you that you can keep your running instances long enough to finish your work. So it may interrupt at any given point of time. And spot also does not guarantee that you can get immediate availability of the instance that you're looking for. So that is one thing that is really important. Or that you can always get the aggregate capacity that you requested. So you have to understand that there are certain limitations of the spot instance to be used, and based on that you have to make your decision. And moreover, the spot instance interruption and capacity can change over time because spot instance availability varies based on the supply and demand, and past performance isn't a guarantee of the future result. Now let's talk about a much more stable hosting platform like instance types or the instance planning type. So that is the dedicated host. So an Amazon EC2 dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. So that is a very good thing, that is fully dedicated to your use. And dedicated hosts allow you to use your existing pre-socket, pre-core, or pre-VM software licenses, including Windows Server, Microsoft SQL Server, SUSE, or Linux Enterprise Server. So these are a very good way of hosting if you have a requirement that you need a fully dedicated server for yourself, which is a physical server, of course. But there are a few differences between the dedicated hosts and dedicated instances. But having said that, it's like dedicated hosts and dedicated instances can both be used to launch Amazon EC2 instances into physical servers that are dedicated for your use. And you must understand there are no performance, security, or physical differences between dedicated instance and instances on dedicated hosts. So you have to remember that there are no physical differences. But there are some differences when it comes to like billing, visibility of sockets, cores, host IDs, or automatic instance recovery, bringing your own license, capacity reservation. All these things are there. So when it comes to dedicated host, you have a per host billing, but for the dedicated instance, we have per instance billing. And when you talk about target instance placement, So in dedicated host, actually it provides additional visibility and control over how instances are placed on a physical server. So you get that idea on how basically your instances are placed, but you do not have that option when it comes to a dedicated instance. When it comes to automatic instance recovery, it is supported in both dedicated host and dedicated instance. But when it comes to bringing your own license, it is only supported by the dedicated host, and dedicated instance does not have that. Capacity reservation is also not supported by dedicated host. You cannot have a capacity reservation in dedicated host, but you can have that in dedicated instance. So these are some of the differences and similarities, but the major difference that I feel is the visibility of socket, course, and host ID. So dedicated host actually provides visibility of the number of sockets and physical cores, but the dedicated instance won't. So remember that. Now let's talk about dedicated instance. So dedicated instance are Amazon EC2 instances that run in a virtual private cloud on hardware that's dedicated to a single customer. So that's a beautiful thing. So it runs on a virtual private cloud on hardware that's dedicated to a single customer. So dedicated instances that belong to different AWS accounts are physically isolated at a hardware level. So it's like a very secure environment, that I would say, because the physical because they are even physically isolated at the hardware level, even if those accounts are linked to a single pair account. However, dedicated instance might share hardware with other instances from the same AWS account that are not dedicated instances. So that's reasonable, but you know that dedicated instances belong to different AWS accounts, are physically isolated at the hardware level. And a dedicated host, on the other hand, that we discussed, is a physical server that dedicated for your use. And with the dedicated host, you have the visibility and control over how instances are placed on the server. So that's the biggest difference that you can say here. Because dedicated instances are AWS EC2 instances, but dedicated host is a physical server that's dedicated for your use. So I hope you got the difference between dedicated host and the dedicated instances. There is one more thing that we can actually discuss, which is on-demand capacity reservation. So this type of reservations actually help you reserve compute capacity for your EC2 instances in a specific availability zone for any duration. And this gives you the ability to create and manage capacity reservations independently from the billing discount offered by savings plan or regional reserved instances. So by creating capacity reservations, you ensure that you always have access to EC2 capacity when you need it for as long as you need it. So that's a very good thing, because you can have the EC2 capacity whenever you need it. You don't have to wait for it. And the best part is that you can create capacity reservations at any time without entering into a 1 year or 3 year term commitment. And the capacity becomes available and billing starts as soon as the capacity reservation is provisioned in your account. And when you no longer need it, you can cancel the capacity reservation to release the capacity and to stop incurring charges. So what are the things that you need when you want to create a capacity reservation? The first thing is basically the availability zone in which you reserve the capacity. Second one is the number of instances for which to reserve the capacity. And the third one is the instance attribute, including the instance type, tenancy, and platform or OS. So remember these points very carefully. So you need the availability zone, you need the number of instances, and the instance attributes, including instance type, tenancy, and platform or OS. But the major important thing that I guess most of you might be interested in is the instance lifecycle. So what are the various states the instance can go through? So an Amazon EC2 instance transitions through different states from the moment you launch it to its termination. So when you launch an instance using an AMI, so it first goes to the pending state, then it goes to the running state, so which you can actually reboot. So it will go to the rebooting state and it will come back again to the running state because it was rebooted. And if you choose to terminate it, it will go to the shutting down state, Then once it has completed the shutting down state completely, it will go to the terminated state. And you can also stop the running instance or stop hibernate it. So once you stop it, it will go to the stopping state, and then you can basically say that it goes to the stopped state. And from the stopped state, you can basically terminate the instance as well, which will go back to the terminated state, or you can just go back to the start state by starting the instance again. So when you start the instance from the stopped state, it'll go back to the pending state and then to the running state. But one thing you have to remember it is that from the terminated state, you cannot go to any other state that instance is terminated. So just remember that. So the whole point for us to remember is there are around 1, 2, 3, 4, 5, 6 states. So one is the pending state. The instance is preparing to enter the running state. An instance enters the pending state when it is launched for the first time, or when it is started after being in the stopped state. So there are two possible combinations, like two possible conditions here. So if the instance is in pending state, either it was first launched or if it was started once it was stopped. So if you had created an instance or launched an instance from an AMI, it will first go to the pending state. Or if you had stopped the instance and you had started it again, then it would also go back to the pending state. Running. So if the instance is running, it is ready for you to use. Stopping. So this state happens when you have stopped the instance, or you have performed the stopped operation or stop hibernated operation. So it goes to the stopping state when these two operations are successful. Stopped. So when the instance is stopped, so instance is shut down and cannot be used, and the instance can be started at any point of time. So when your instance has already gone to a state where it is now stopped, so it is either shut down and cannot be used, or it can be started at any point of time. So the next one is shutting down. So if you have terminated your instance, or you have performed the terminated operation just now, it will first go to the terminated operation. So it will first go to the shutting down state. Next, after you have performed the shutting down operation and it has completed successfully, it is permanently deleted. So that is when it goes to the terminated state, and thus it cannot be started again. And note that you are only billed for the running state. And if suppose your instance was in the hibernating state, or if it was preparing to hibernate, it is only billed in these two conditions: running or stop hibernated, or if suppose it is going to the hibernated state. It will not be billed when it is stopped, but if it is preparing to hibernate, then it will be charged. So these two conditions, running and if it is preparing to hibernate, are only these two conditions which can, allow AWS to charge you. Other than that, no other condition is applied when your billing is into your billing. And other than that, no other condition is applicable when you will be billed. So what happens when you launch the instance? So when you launch an instance, it enters the pending state, I told you. So the instance type that you specified at launch determines the hardware of the host computer for your instance, and AWS will use the AMI that you specified at launch to boot the instance. And after the instance is ready, it will go to the running state, and thus the billing will start. And as soon as your instance transition is set to running state, you are billed for each second. Remember that, with 1 minute minimum that you keep the instance running, even if the instance remains idle and you don't connect to it. So even if you don't connect to it and it remains idle, still it will be billed. So you have to either stop it or terminate it if you don't use it. And one more important thing is very important, because like when you start or stop an instance, so if your instance fails a status check or is not running your application as expected, and if the root volume of your instance is an ABS volume, you can start and stop your instance to fix the issue that you're having. So if there is a status check and it has failed, and your application is not running as expected, and your instance is backed by EBS volume, you can stop and start your instance to fix the issue. And when you stop your instance, it enters the stopping state and then the stopped state. And AWS does not charge its usage or data transfer fees for your instance after you stop it. But your charges will be applied for only the EBS volume that you consume. And while your instance is in the stopped state, you can modify certain attributes of the instance, including the instance type. So that is a very good thing. And when you start your instance, it enters the pending state again. And we move to the instance to a new host computer. And once you have changed or modified anything, when you start your instance, it enters the pending state, and AWS moves the instance that you have to a new host computer. But it remains same for some of the use cases. But when you start your instance again, it will go to the pending state, and AWS moves the instance to a new host computer. And when you stop and start your instance, you lose your data that you have in your instance store volumes on the previous host computer. And that is the reason why it actually happens. Because if it is in the instance store volume and if the host changes, then you will surely lose the data. And your instance retains its private IPv4 address in only conditions where an elastic IP address is attached to it. And what about the IP address then? So if the instance is restarted or anything, it will only retain its private IP or private IPv4 address if there is an elastic IP address associated with it, or the network interface is still associated with your instance. So each time you transition an instance from stop to running, AWS charges per second when the instance is running, with a minimum of 1 minute every time you start your instance. So remember that. We have already discussed that in length. And the next one that we have here is EC2 fleet and spot fleet. So when there is a requirement to launch a fleet of instances, mostly we look in front of EC2 fleets and spot fleets. So you can use an EC2 fleet or a spot fleet to launch a fleet of instances, like a collection of instances. Fleet, like a fleet of ships, like that. In a single API call, a fleet can launch multiple instance types across multiple availability zone using the on-demand instance or reserved instance and spot instance pricing option or purchasing options together. So we have multiple things that we can use it with. We have like EC2 fleet, we have spot fleet. So you can choose one among them to basically perform your required operation. So as the name suggests, when it comes to EC2 fleet, and EC2 fleet contains the configuration information to launch a fleet or group of instances. And in a single API call, a fleet can launch multiple instance type across multiple availability zones using the on-demand instance, reserved instance, and spot instance purchasing option together. So what we can do using the EC2 spot or EC2 fleet, so we can actually define separate on-demand and spot capacity targets and the maximum amount you're willing to pay per hour. We can actually specify the instance type that works best for your application. We can specify how EC2 should distribute your fleet capacity within each purchasing option. And you can also set a maximum amount per hour that you're willing to pay for your fleets. And EC2 fleet launches instances until it reaches the maximum amount. Until it reaches the maximum amount. And when the maximum amount you're willing to pay is reached, when the maximum amount you are willing to pay is reached, the fleet stops launching instances even if it hasn't met the target capacity. And what happens if the maximum amount is reached? And what would happen if the maximum amount is reached? So in that case, when the maximum amount you're willing to pay is reached, the fleet stops launching instances even if it hasn't met the target capacity. So let's suppose you are paying 100 rupees. And based on the pricing, it was able to launch only 40. But the target capacity that you wanted was 50. So as the maximum amount has reached that you're willing to pay, then the fleet stops launching instances even if it hasn't met the target capacity. And now coming back to the spot fleet. So just like EC2 fleets, spot fleet is also a set of spot instances and optionally on-demand instances that is launched based on criteria that you specify. So the spot fleet selects the spot capacity pool to meet your needs and launches spot instances to meet the target capacity for the fleet. And by default, spot fleets are set to maintain target capacity by launching replacement instances after spot instances in the fleet are terminated. So as I already told you that the instances in spot instances are not like permanent or what do you say, uh, trustworthy. That would be another word, like trustworthy. So they can get interrupted at any given point of time. But what happens with the spot fleet? But with the spot fleets, they set they help us to set. But what happens with the spot fleet is that they are set to maintain target capacity by launching replacement instances after spot instances in the fleet are terminated. So you can submit a spot fleet as one-time request, which does not persist after the instance has been terminated. You can also include on-demand instance request in a spot fleet request. So you can have both of them. So these are some of the benefits of using spot fleet, and we can move on with this. And when it comes to monitoring the AWS EC2 instances, so as we all know that it is an important part for maintaining the reliability, availability, and performance of your EC2 instances and your solutions. So you can collect monitoring data from all of the parts of your AWS solution so that you can easily debug a multi-point failure if that occurs. So before you start monitoring EC2, you should create a monitoring plan, so which would help you align with your goal. So the goals could be like, what are your goals for monitoring, what resources you will monitor, how often you will monitor these resources, what monitoring tools you will use, who will perform the monitoring task, and who should be notified when something goes wrong. So after you have defined your monitoring goals, and have created your monitoring plan, the next step would obviously be is to establish a baseline for normal EC2 performance in your environment. So what level of performance that you want, and if it exceeds that, you have to send out notifications. So that actually becomes a threshold for your performance in your environment. So you should measure EC2 performance at various times and under different load conditions. So as you monitor EC2, you should store a history of monitoring data that you collect so that you can compare current EC2 performance to its historical data. You can identify normal performance patterns and performance anomalies. So like, let's suppose there is a spike, and if you don't have a historical pattern or a data that you can compare it with, you will never be able to know that there is a spike or there is a dip. For example, you can actually monitor CPU utilization, disk IO, and network utilization for your EC2 instances. And when performance falls outside your established baseline, you might need to reconfigure or optimize the instance to reduce CPU utilization, improve disk IO, and reduce network traffic. So let's suppose there is an instance which is like going over 95% CPU utilization every time. So you can just launch another instance and run them parallelly within your load balancer to actually reduce that high CPU utilization in that case. So that can also be automated using monitoring. So to establish the baseline, you should at the minimum monitor the CPU utilization, the network utilization, disk performance, disk read and write, and also you can go deep with comparison with the memory type. So it would be like memory utilization, disk swap utilization, disk space utilization, page file utilization, log collection, all these things. And this can be helpful if you're using CloudWatch agents, which will help you collect metrics and logs from EC2 instances and your on-premise servers as well. So you can collect these data and you can perform operations and see how your instances are performing. And based on that, you can create alarms as well. And you can attach your policies to the alarms, which can actually perform automated recovery points for you, so that you don't have to worry about if anything is going beyond your threshold that you have set. So I hope and wish that you enjoyed the podcast on AWS EC2. And please do provide your comments on the podcast for us to make this better for you. And if you have any service recommendations that you feel is the best fit for the podcast, please do share them in the comments as well. And these videos really take a lot of time to make, so please make sure that you help the channel by subscribing and hitting the notification bell. And please do like and share the podcast as well. So this is something that I want to request you once again, that please do subscribe to the channel. It really helps me keep my motivation alive, and it really helps the channel grow. And I'll also update the Spotify link in the description, so you can listen to this on your Spotify account and your Spotify application. So that's all from my side today. I'll meet you in the next one. Until then, stay safe, stay healthy. It's Pythoholic signing off.